Okay, this is Miss Delosier. This is the last 9 questions. There's people here. Deal with it. Number 41. Which of the following statements best represents the relationship between the light reactions and the Calvin cycle? The light reactions provide ATP and NADPH to the Calvin cycle, and the cycle returns ADP, inorganic phosphate, and NADP plus. The light reactions. That's true, but I don't know that that really best illustrates it. Light reactions provide blah to the carbon fixation step of the Calvin cycle. The Calvin cycle provides water and electrons to the light reaction. That is false. Light reactions supply Calvin cycle with carbon dioxide. Wrong. Light reactions provide Calvin cycle with oxygen for electron flow. Wrong. There's no relationship. Wrong. So I guess my answer is A. Yay. Can plants keep stomata closed in the daytime, thus reducing loss of water? They can do this because they fix carbon dioxide into organic acids during the night, because you have to do it sometime, and if they're not doing it during the day, they're doing it at night. The alternative pathway of photosynthesis using C4 or CAM systems are said to be compromises. Why? Each one minimizes water loss and the rate of photosynthesis. No, because you don't want to minimize photosynthesis. That's stupid. That's not the point. C4 compromises on water loss, and CAM compromises on photosynthesis. No. Both minimize photorespiration but expend more ATP. Yes. And CAM allows more water loss, while C4 will allow CO2 in. No. And C4 plant allows less water loss, but CAM plants allow more water loss. None of those make sense, you guys. I don't even know why I put that question on your review, because there's only one possible answer there. Plants photosynthesize only in the light. Plants respire both in the light and the dark. Yeah, I'm going to go ahead and clear that now and scroll down. And if you need help on 44, you might actually need to email me several times tonight. Theodor Engelmann illuminated a filament of algae with light that passed through a prism, thus exposing different segments of the algae to different wavelengths of light. He added aerobic, meaning they need oxygen, bacteria, and then noted in which areas the bacteria congregated. He noted that the largest groups were found in areas with red and blue light, meaning they made the most oxygen. What did Engelmann conclude about the congregation of bacteria in the red and blue lights? The bacteria released excess carbon dioxide? No. Bacteria congregated in these areas due to an increase in the temperature? No. Bacteria congregated in these areas because these areas had the most oxygen being released? Yes. Bacteria are attracted to red and blue light. Stupid. Bacteria congregated in these areas due to an increase in the temperature. The only answer there that has anything to do with wavelength and photosynthesis is C. An outcome of this experiment was to help determine the relationship between, you guys, what are we determining the relationship between? Wavelength and photosynthesis. So, heterotrophic and autotrophic? No. Wavelength and rate of respiration? No. Wavelength and heat? No. Wavelength and photosynthesis? Yes. D. And moving on, number 47. If you ran the same experiment without passing the light through a prism, if I don't pass the light through a prism, they all get the same light, it'd all be white light, I would expect to find the bacteria what? They would be evenly spread out. But that does not mean that the answer is there would be no difference in results. There'd be no difference in results between areas of the algae, but this indicates that there's no difference in the results between the first experiment and the second experiment, which is wrong. The bacteria would be relatively evenly distributed. That is true. So, B.
Okay. They just want to stay in my room.
Yay, last questions. A spaceship is designed to support animal life for a multi-year voyage to the outer planets of the solar system. Plants will be grown to provide oxygen and to recycle carbon dioxide. Since the spaceship will be too far from the sun for photosynthesis, and probably not have windows, an artificial light source will be needed. What wavelengths of light should be used to maximize plant growth with a minimum of energy expenditure? If you did not say red and blue, then you need to go and rewrite your seed germination project before it is due tomorrow night at 10 p.m. because that was the entire point of that project. If the power fails and lights go dark, what will happen to carbon dioxide levels? If the power fails and the lights go out, there's no more photosynthesis. If there's no more photosynthesis, then I'm not using any carbon dioxide. So my carbon dioxide levels will increase and my oxygen levels should decrease, although I didn't ask you about the oxygen levels. So the carbon dioxide will rise as a result of both animal and plant respiration, because yes, both animals and plants do respire. Carbon dioxide will rise as a result of animal respiration only. The only is false. Carbon dioxide will remain balanced. That's ridiculous. Carbon dioxide will fall because the plants will increase the carbon dioxide fixation. How? You have to have the NADPH from the light reaction. Carbon dioxide will fall because plants will cease to respire in the dark. Yet the plants will eventually cease to respire in the dark. It's called dead. But initially, my answer is going to be A. Which of the following sequences correctly represents the flow of electrons during photosynthesis? Chlorophyll, like initially you have the sunlight hit the chlorophyll, right? So the sunlight hits the chlorophyll. So sunlight hits the chlorophyll. And then the chlorophyll is going to go to the NADPH, and then that's going to go to the Calvin cycle. Do you have one that says that? Do we have one that says that? NADPH to oxygen to carbon dioxide? No. Water to NADPH to the Calvin cycle? Maybe, because we get some water here, right? We use some of the, right there. NADPH to the chlorophyll to the Calvin cycle? No. Water to photosystem 1 to photosystem 2. Let's see. We're going to have to decide between one of these two, right? I'll put C back in there. So what do you guys think it is? Am I taking the electrons from the water and giving them to the NADPH? That would be, water is photosystem 2, right? NADPH is photosystem 1, and then going to the Calvin cycle. NADPH is photosystem 2. Chlorophyll is both photosystem 1 and 2. Water to photosystem 1 to photosystem 2. So you have to think. This one's tricky. This is why I put it on here. It looks easier than it is. So think about it. What's the order that they're going to go in? You go in the quad. We've got photosystem 2 going ahead, and those electrons move to photosystem 1, and then that eventually moves to the Calvin cycle. So I would say that this is a poorly written question, and then I would say that the most right answer of that is actually B. So that's it. I will be available online probably between, I don't know, maybe 7:30 and 9:30 tonight. And I guess if you send me a tweet, I'll get it before your test tomorrow morning, but don't count on that. Okay? Bye. Good luck.